824. Suppose we have a random sample x1 through xn. They are independent identically distributed, or IID, following the chi-square distribution, with the 1 as the degrees of freedom. Then we define the yn to be the sum of these random variables. Then we want to show that the limiting distribution of this random variable, which is a function of the yn, is approximately equal to the standard normal distribution. Okay, apparently here we're going to use the central limit theorem to prove this. Okay, to use the central limit theorem, we need to show that this can be shown as a standardized sample mean. Well, already we have already showed this is already given as a sum. So yn over n will be just the sample mean of these things. So if you can show that this is the true mean of this distribution, and this is sigma over square root of n, where sigma is the standard deviation of this, then we're done. Okay, so this is the only two things that we need to show. So looking at this distribution, we know that it's just a chi-square distribution with the 1 as a degree of freedom, or you can treat it as a gamma distribution with the 1/2 as alpha and 2 as the beta. So in that case, the expectation of this distribution will be just 1/2 times 2, and that's equal to 1. So every one of them have the same expectation, which is 1. The variance of each of these guys is just 1/2 times the 2 squared. If that's alpha, that's like the beta. So alpha beta squares is the variance of the gamma distribution. So that's why the variance is this. Now we're just basically done, because this is just the mean. This is just the mean. This is just the variance. So like this is the sigma square. So that's why when we treat this as the sample mean, then this is the mean, which is the 1 here, and then we have the 2, which is this thing here. That's why we have, by the central limit theorem, we know that the limiting distribution of this standardized sample mean of these xi's is normal, standard normal.